All right, so 6.1, we're going to change it up a little bit, kind of go in a totally different direction, but this is something that we have seen before. We're looking at roots and radical expressions. So here we just have a few vocab words. The index is the little number out front of our radical. In the past, we've dealt with like radical square root x. When it doesn't have any number right there, it implies that that is a 2. That's why when we break it down, we circle groups of 2. But now we're going to be dealing with other numbers besides 2, and it'll be written in this spot what our index is. We have the radical sign, which is just this root, and then the radicand is what's underneath it. So just vocab, nothing to worry about right now. So recall that the radical symbol, this guy, is used to indicate roots. The index is the small number to the left of the radical symbol that tells which root to take. For example, this represents a cubic root since there's a 3 outside. So since 2 cubed is 2 times 2 times 2, and that's equal to 8, the cubed root of 8 is equal to 2. So we're going to practice this. Don't stress it. It's just, again, explaining things in words. One thing that we do need to know on the next page is when we have an exponent that's a fraction, that's the same thing as a square root or a root. So here we have 1/2. This number down below is our index. So in the denominator, that is your index. Again, when our index is 2, we don't write it here. It's just implied that that's a square root. In the denominator here, our index is 4. So we just write that out front of our radical. And then same thing with this one too. This is our index and 7 is our index. So whenever you see a fraction as your exponent, it's the same thing as a radical with that index. So looking at example A, we have 343 to the 1/3 power. So this is the same thing as saying the cubed root of 343. Anybody know what any factors of 343 are? Take a guess. What do you think? Seven is a factor, so we have 7 and 49. 7 is a prime number, so we can't break that down anymore. What are 2 factors of 49? 7 and 7. Whatever our index is, that tells us how many numbers we have to circle. So in the past, we only circled groups of 2 because we only dealt with square roots. Now we have the cubed root. Our index is 3, so we circle groups of 3. So we would circle all 3 7s, and whatever we circle comes outside as a whole number. Do we have anything that's not circled? Nope. We only had 3 7s, that was it. So nothing stays inside of our radical. So our answer is just 7. Any questions here? All right, so let's look at the next one. 32 to the 1/5 power is like saying the 5th root of 32. And 9 to the 1/2 power is the square root of 9. So we just want to find what each of these are separately and then just add them together. So what are our factors of 32? 8 and 4, perfect. What are some factors of 8? 4 and 2. And factors of 4? 2 and 2. We said factors of 4 are 2 and 2. I'm just going to drop down all these 2's. We're circling groups of how many here?
5.
Groups of 5. How many 2's do we have? 5. So we circle all of them. So what's our answer going to be here? 2. So we just simplified the fifth root of 32. Now let's simplify the square root of 9. What are two factors of 9? 3 and 3. That's it. Can't do anything else. We're circling groups of how many here? 2. So what would our answer here be? 3. What's 2 plus 3? 5. So 5 is our answer. All right. So what's our index for this one? 4. So we have the fourth root of 81. What are factors of 81? 9 and 9. What are factors of 9? 3 and 3. We're circling groups of how many? 4. So what's our answer? 3. Let's look at the next one. This is the square root of 121 and the fourth root of 256. Let's just look at our square root of 121 first. 121 is actually a perfect square. Anybody knows what the square root of 121 is? 11. Perfect. So we have 11 and 11. Circle groups of 2. So our answer is just 11. Let's look at the next one. What are some factors of 256? Let's see. 256 divided by 8. Yeah? 8 and 32. What are factors of 8? 4 and 2. Factors of 32? 8 and 4. Factors of 4? 2 and 2 and 2. Factors of 8? 4 and 2 and 2 and 2. So I'm just going to rewrite all of these again because we have 2 and 2 and 4. So 2, 2, 2, 2, 2, 2. We're circling groups of how many? 4. So we only want to circle 4 2's and then 4 2's. So what comes out? 2 times 2. So remember, if you take out more than one thing, you multiply them together. And what's 2 times 2? 4. So we have 11 plus 4, which is? 15. That's our answer here. All right, so sometimes we have a number on top of our fraction here. The bottom is still our index. The top is our exponent still. So we could write this as the cubed root. So again, we have our index here. The denominator goes out front. The numerator stays up top. So we could write it this way with the 2 on the outside, or you could write it this way with the 2 on the inside. So both of these are the same thing. They're the same. So notice how in the top one, we found the cubed root of 8 first. So that's 2, and then we squared it at the end. On this one, we squared 8 on the inside, which was 64, and then found the cubed root of 64, and we got the same answer. So it's just a different way of doing the same problem. So you can write it either way. Let's look at some examples. So simplify the expression. Which number is our index? What's going to go out front? The 4 goes out front. And then we have 16. And the exponent stays up top. So the numerator stays on top. Let's find the fourth root of 16. What are factors of 16?
4 and 4.
4 and 4. What are factors of 4? 2 and 2. We're circling groups of how many? 4. So what do we get when we simplify the fourth root of 16? 2. But then we have 2 cubed. We can't forget to cube it. So what's 2 cubed? Perfect. This is 2 times 2 times 2. So that gives us 8. All right, let's look at B. Which numbers are index? The 5. So you have the fifth root of 1 cubed. Number on top stays on top. What are factors of 1? 1. So this would be like 1 times 1 times 1 times 1, however many ones we want it to be. So what's the fifth root of 1? 1. And then what's 1 cubed? 1. So 1 to any exponent will always be 1. You could have 1 to the power of 1 million.
Wait, but we still need to write the
No.
So if we see a 1, we just write 1.
Yep.
Okay.
1, no matter what the exponent is, will always be 1. All right, C. What is our index? 3. So 3 goes out front, 27 goes on the inside, and 4 stays up top. What are some factors of 27? 9 and 3. What are factors of 9? 3 and 3. We need to circle groups of how many? 3. So we circle all 3 of our 3's. So what would our answer for the inside part be? 3. But we still have 3 to the 4th power. So this is 3 times 3 times 3 times 3. If it helps when doing this in your head without a calculator, I always multiply 3 times 3, which is 9, and then I'll multiply these 3's, which is 9, and then you can multiply 9 times 9. What's 9 times 9? 81. Another way you could do this is multiply 3 times 3 and then 9 times 3, which would be 27. But then when you get to 27 times 3, it gets a little bit more tricky because then, I don't know, big numbers. So it's easier to, you guys know what 9 times 9 is. You may not know what 27 times 3 is. So our answer here is 81. Any questions on this page? All right, next one. So what is each real number root? What are factors of -8? -4 and 2 are factors of -4. 2 and -2. So I'm just going to ignore the negative for right now. So we have 2, 2, 2, and 2. How many numbers do we need to circle? 3. So what comes out? A 2. So for this one, which there wasn't a slide to explain it, but whenever you have an odd number as your index, so an odd index, and a negative on the inside, your answer is going to be negative. So odd index and a negative on the inside, your answer is negative. If you have an even index, and you have a negative on the inside, so let's say -2. What do we do with the negative on the inside? What have we done with the negative on the inside in the past? Not turn it positive. It's take it to the outside and turn it into what? An I. So if you have an even index, it becomes an I. If you have an odd index, the answer is negative. All right. Let's look at C. So here, is our index even or odd? It's even. 4 is an even number. So what do we do with that negative? Take it on the outside and put it into an I. What's the fourth root of 1? Because now you have I times the fourth root of 1. 1. So this would just be 1 times I, which is just I. All right, let's look at D. So first thing we have to do is the inside of our radical. So we have negative 2 squared. So this is like square root of negative 2 times negative 2. What's negative 2 times negative 2? Positive 4. So the square root of positive 4. What are 2 factors of 4? 2 and 2. We're circling groups of how many now? 2. So remember, when there's no number on the outside, it's implied that it's a 2. So we circle groups of 2. So what would our answer be? 2. And turn it into an I. So we turned that negative into an I, so that I is outside. And then we just have the fourth root of 1. We said 1 to any exponent is just 1. So the fourth root of 1 is just 1. So that gives us 1i. And that's like saying 1x. You don't have to put the 1 in front of the I, so then it's just I. If you did leave the 1 in front of the I, totally fine. You wouldn't get points taken off. But if you saw it on like a standardized test, it would just be I. Or if it was multiple choice, it would just be I. The 1 wouldn't be there. All right, we got a few more. Yes. So on this page, we have variables under our radicals, but we're going to do the same thing. So we want to break everything down as much as possible. Let's start with the number. What are our factors of 16? 8 and 2. What are our factors of 8? 4 and 2. And our factors of 4? 2 and 2. Now here we have x to the 8th power, so this is like saying x times x times x times x 8 times. 1, 2, 3, 4, 5, 6, 7, 8. We're circling groups of how many here? 2. Remember, when it's not written, it's implied that it's a 2. So we circle pairs. So we have a pair of 2s, a pair of 2s, a pair of x's, a pair of x's, a pair of hexes, a pair of x's. How many groups of 2s do we have? 2. So we're going to take out 2 2s. How many groups of x's do we have? 4. So we take out 4 x's. And we just multiply everything together. So what's 2 times 2? 4. And how many x's do we have? 4. How do we write that? X to the 4th power. So that's our answer. All the x's came from x to the 8th power. So this is like saying 8 x's, so I just wrote out all the 8 x's. All right, let's look at B. So let's write out everything we have on the inside. We have 6 a's, so a times a times a. That's 5, 6, and 9 b's. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to circle groups of how many? Groups of 3. So we have 3 A's, 3 A's, 3 B's, 3 B's, and 3 B's. How many groups of A's do we have? 2. So how many A's come to the outside? 2. How many groups of B's do we have? 3. So we take out 3 B's. How would we write this? Awesome. A to the 2nd power times B to the 3rd power. Good job. Whatever our index is here, that number out front, that's how many we need to circle in each group. So that's why we circled 3 in each group. All right, let's look at C. So here we have 8 x's, 3, 4, 5, 6, 7, 8, and 12 y's. 4, 5, 6, 7, 8, 9, 10, 11, 12. We need to circle groups of how many?
Four.
Groups of 4. So we circle 4 x's. Oh, I didn't even, oh yeah, those are x's. 4 x's, 4 y's, 4 y's, and 4 y's. How many groups of x's do I have? 2. So 2 x's come to the outside. How many groups of y's do I have? 3. So I take out 3 y's. So how would I write my answer? Awesome. X squared times y cubed. Another way we can solve problems like this, which if you like to write it out, I feel like that's probably the easiest way, so stick to that. But if you had like really, really big numbers in here, like if you had x to the 27th power and you didn't want to write out 27 x's, another way we could do this is we know that our index goes in the denominator of our fraction. So this would be x to the 8 over 4 and y to the 12 over 4. So what's 8 divided by 4? 2. So we're left with 2 there. And then what's 12 divided by 4? 3. So you could do it this way too. Just take whatever your index is and put it on the bottom in the denominator. The denominator. See, we got the same answer.